Number 16. Consider a ray of light incident on thick glass container full of water. Angle of 40 degrees is shown. Find the angle of refracted ray as the light enters the glass from the air. All right, mark this as theta 2. So this is the angle, theta 2, of the refracted ray. So here's our perpendicular. This is the incident at 40 degrees, or theta 1. Let's call the air theta 1. So N1 is 1, N2 is here, and 3 is here. So N1 is air, N2 is glass, and 3 is water. Okay, so there's theta 2. So refracted ray means Snell's law. And we've got 1 and 2, so we'll do N1 sine theta 1 equals N2 sine theta 2. N1, so N1 is 1. Sine theta 1 is sine of 40 degrees. N2 is 1.5. And sine and theta 2 is what we're looking for. Divide both sides by 1.5. And then take the inverse sine. So theta 2 is inverse sine of 1 over 1.5 times sine of 40 degrees. Inverse sine of, let's put it in parentheses just to be safe, 1 divided by 1.5, and then get outside the parentheses, so I did some little parentheses here, times sine of 40. Looks good. 25.4 degrees. Looks good. That's theta 2. Determine the angle of the refracted ray as light enters the water from the glass. Water from the glass. So now we're in here, and so the refracted ray would be here. It says to call it theta 3. Theta 2, the incident angle, is always with respect to perpendicular, so that's the angle here. But since we've got two parallel lines, and these are alternate interior angles for a line cutting the two parallel lines, this is also going to be theta 2. So we are good here. So we can do another Snell's law. So N2 sine theta 2 has to be equal to N3 sine theta 3. N2 is 1.5. Sine theta 2, which we just got, is 25.4. Equals N3, 1.33. Sine of theta 3 is what we're looking for. Again, solving, divide by 1.33 on both sides. And then do the inverse sine. So theta 3 is inverse sine of 1.5 divided by 1.33, and then times sine of 25.4 degrees. Inside of the inverse sine. All right. Inverse sine of, let's put some parentheses, 1.5 divided by 1.33, and then multiply that by sine of 25.4 at 28.9 degrees for theta 3. All right. Determine the critical angle for the glass to water boundary. So we're talking about right here. Light's coming in, and what's the biggest angle, or what does angle, I guess the smallest angle, anyway, the smallest angle that causes the light to, basically when the angle is here, when the light that gets in the water ends up being 90 degrees, and so then it's all going to, after that, when you get bigger than theta critical, it's all going to be inside, right? And so in general, we have the formula sine of theta critical equals N2 over N1. Or theta critical is inverse sine of N2 over N1, where N1 is where the light starts, N2 is where it ends. So in this case, it's starting in the glass. We're looking for the total internal reflection in the glass. So N1 is N glass. So theta critical is inverse sine of and it's going to the water, we said, so N water over N glass. N glass. All right, so total internal reflection is not possible if, when we try to put these things in, the N values in, we are trying to take inverse sine of something bigger than 1, and we know sine can never be bigger than 1. So theta critical in this case is inverse sine of water, and water is 1.33, and glass is 1.50, so we're okay because the top is smaller than the bottom. So we'll do inverse sine 1.33 divided by 1.5. 62.5 degrees is theta critical for glass to water. Okay, next one, find the critical angle for glass to air. So now we're wondering about over here, what's the angle that makes it start coming back in and be all reflected over here. So again, same formula but different ends. We've got inverse sine of, where is it going to this time? Air. So in air, and where is the light starting, or where is the light basically staying, is in the glass again. All right, so inverse sine of, and air was 1 and glass is 1.5. So again, we're good because the top of the fraction is smaller than the bottom. So theta critical glass to air is inverse sine of 1 divided by 1.5, 41.8 degrees. Okay, find the reflected angle for the light entering the glass from the air. Sketch the reflected ray on the picture. So reflected is the bouncing off like a mirror kind of reflection, right? And so something like this, the light comes in and is reflected off, and this would be theta reflected right in there. And we know from the law of reflection, theta reflected equals theta incident. In this case equals theta 1, which is 40 degrees. So theta reflected is 40 degrees. Okay, so there's a reflected angle and we drew it on the picture. Okay. Let's look at